everyone, welcome to Xiaohei Classroom. In this section, we introduce the simple series PLC to realize the communication operation of PLC as Modbus TCP master station through Modbus FB library instructions. First, we need to add the Modbus FB library to the library management. Search for Modbus FB, click OK when you find it, and add it to the library manager. After expanding the library just added, you can see the function blocks contained in the bread as the master station. The PLC uses the client CP instruction of the main client folder to configure the parameters. Then you can use the following instructions to read and write to each area address, such as reading and writing to the holding register, reading and writing to the coil, etc. You can directly see the description of the instruction and the meaning of the pins here. Next, we will directly see how to use these FB blocks to program the communication program in the program. These instructions are all FB. We need to instantiate the variable declaration area before we can call the instructions. The program mainly uses the TCP driver instruction, as well as the reading and writing of the holding register area and the coil. Then make a fine state machine below, which can realize the polling trigger access of the instruction. The first is to assign the Internet Protocol address of the slave, because the debugging assistant is used as the slave. So the IP of the slave is the IP of the computer. And then here's the assignment to the port number. Then use this variable to trigger the connection with the slave. And here's the call to the FB block. Then the following is the call to read the hold register. Then the first pin fills in the instantiation name of client FBTCP. Then here is the instruction trigger variable, which can be accessed once it is triggered. For the device that converts the network port to the serial port, the unit ID needs to be provided. The pure network port communication does not need to be managed. Just set one directly. Then fill in the starting address of the holding register we want to access, the access length, and the address where the read data is stored. Then this is the write hold register, which has also been instantiated, and the write address has also been created. This is configured to write to 10 consecutive addresses with a holding register offset of 10. Then go down and read the coil. Read the data with the starting address as offset 0 and length 1, and then store it in coil value. Then the write coil writes the same address as the read coil accesses. Then the following words are the programming of the finite state machine process. And then through the judgment of the communication status of each instruction, decide whether to enter the access of the next instruction and realize the function of polling to trigger access. The first is to access the read-hold register. When the read is successful or an error occurs, it jumps to the write-hold register operation. Then when the write holder instruction is completed or an error is reported, the coil is accessed again, and it is executed in a reciprocating cycle. Now download this project and see how it works. Here we use the debugging assistant as a Modbus slave. First, let's take a look at the data transfer of the read-hold register. Let's trigger the connection command first. You can see that the value has been read. Continue to modify the slave data. You can see that the master can obtain the latest slave data in real time, indicating that the communication has been successful. Let's take a look at the operation of the write-hold register and the read-write coil. You can see that it has been written successfully. Let's take a look at the access of the coil. Because writing and reading operate on the same address, we can directly write to see if the reading is successful. The above is the simple series PLC through the Modbus FB library command as your Modbus TCP master configuration operation. That's all. Thanks for watching.